I'm JK, an electrical engineer. Please, if you are new on this channel, please consider subscribing to the channel JK Solutions. Thank you. Now, this video is about how to distribute a high electrical power at medium voltage, especially in a big office complex. So, without making use of RMU. That is what this video is all about. So, in some of my previous videos, I talk about how to carry out electrical power distribution, especially high power distribution at medium voltages, by making use of a ring main unit. So, but that one is where we make use of a ring main unit, especially where we have wide area for the distribution, such as an estate or a settlement. So where we have a very big settlement, then we have enough space to make use of ring main unit. But where we have a very small space, and then maybe in that small space we have high-rise buildings in addition to other buildings where we don't have enough space for all these big electrical equipment. So we make use of medium voltage distribution since the power is high, but we may not make use of ring mains unit. So as we are going to see shortly. Moving on. Here we have electrical power distribution for big office complex. As usual, it is known that we usually have three sections. We have the mains supply section, the generator or the emergency power supply section, and we have the common bus section. This one, that is, we have the mains, the generator, we have the interlock and the common bus section here going to the load. So here we are to distribute an electrical power which is about 4 MVA. 4 MVA. Alright? And that's why we are having two number 1.5 MVA generator. 2 times 1.5 will give us 3 MVA plus 1 MVA, that is 4. So we just have this 500 kVA generator in order to have some power excess. Alright? So now we have this. We have one transformer to one generator for stepping up. Then we will have this MVP panel. The MVP panel is a multi-purpose panel. Yeah. This MVP, meaning medium voltage panel, is a multi-purpose panel. It performs the function of automatic mains failure device, phase sequence device, load shedding, synchronization of the generators / transformer paralleling. We have many transformers here. It is this panel that does it performs all those functions. So, and it receives a signal from the main 11 kV panel, which is the interlock panel. In case there is a mains failure, there is a remote sensing from this panel, the main 11 kV panel, to this synchronizing panel. And then there are signals S1, S2, S3, S4 to the generators as well, to determine when to switch on the generators, or which ones are to be switched on and which ones are to be shut down. So that is why it is called a multipurpose panel. We have step-up transformers, there are 4 of them, one generator. So, and then now this panel is low voltage panel, LV panel, and it is called model case circuit breaker MCCB panel of IP65, because it has to be made waterproof if it is installed outside. Alright, there must be a kind of roof on or a shed on it. So now we come to from here. These generators, they all deliver power to this bus section. So, and the mains delivers power to this box section. So this is a metering unit for the mains, metering unit for the generator system. And then we have the interlock. This circuit breaker and this circuit breaker, they alternate. One closes while the other opens. So when the other one closes, the other one will open as well. So in case there is any mains failure, this circuit breaker will immediately, it will sense, it will open just as the panel is sending signal to this panel. So, and the generators will start. When they start, they deliver power here. This circuit breaker closes and this one opens. And when the voltage from the mains is restored, so this one closes and the generators are shut down and this circuit breaker opens. So here we have the common bus section here, where the major torque is all about. That is what this video is all about. Now here we have a small 11 kV panel. Alright, instead of having the conventional ring main unit network here. So we have this panel, this 11 kV panel, and we have vacuum circuit breakers inside. All these PCBs, they are all vacuum circuit breakers, and they are for medium voltage distribution. Alright, so now we have this circuit breaker feeding this transformer. Instead of having RMU before the transformer, in most cases where we have a very small office space comprising maybe high-rise building in addition to other buildings, the switch room, which some people may call it a switch center, is not usually far away from the buildings. So we may not expect this transformer to be far away from this 11 kV panel. So we go directly through this circuit breaker to this step-down transformer. This one, SU means step up, while this one S/D means step down. Alright, so from here now we go to MCCB panel, and then on this side also we have these step-down transformers. We go to MCCB panel, that is a model case circuit breaker panel. So from the MCCB panel, we can have assorted loads or assorted buildings. So let's say we have a high-rise building, maybe we have up to 4 in the same place. Alright, so we can use this line to feed one rising means bus bars chamber. Okay, we know when we have a high-rise building, we can, it could be difficult, maybe like a 15-17 story building. It could be difficult to be running cable from the ground floor to the last floor. So instead we choose to make use of rising means bus bar chamber. We are going to see that one later. Alright, we are going to discuss about how to make use of rising means bus bar chamber in the building, how to make use of the chamber to do the distribution. Alright, so we have rising means bus bar chamber here, and then we have other outgoing feeding some other loads. So the same thing is applicable to this. Let's say we have one rising means bus bar chamber here also. So, and then here we have their typical. So you select the kind of feeding system depending on the kind of load. So here, if you have more high-rise buildings, you feed as many as this system can take. So here, it should not be forgotten that the power that we have here is 4 MVA. Alright, so and when it is 4 MVA, we cannot afford to feed the loads that are bigger in magnitude than 4 MVA. Meanwhile, there are 4 step-up transformers, 1, 2, 3, 4, and these are their ratings. For SUTS1, that is step-up transformer 1, this is 800 kVA, this one is 1250 kVA, this one is 1.6 MVA, which is 1600 kVA, and for TSSU4 is also 1.6 MVA, 1600 kVA. Then we also have 4 step down transformer. The transformers are stepping down the 11 kV to 400 volts. That is from medium voltage to low voltage. So, and these step down transformers, they are sized according to the magnitude of the loads to be supplied, or according to the magnitude of the loads to be powered. So that's how to do electrical power distribution, especially if the power magnitude is high, especially for a very small area, but where we have a high-rise building or so many clusters of buildings in the same place. I mean, compared to a very big settlement. Here we have a very small area, but with high electrical power demand. So that is the situation. And please, if you find the video useful, please consider subscribing to my channel, JK Solutions channel. Thanks for watching.